morning, one and all. Good morning. The subject name is compiler design. Previously, we have discussed about some of the problems which are related to syntax, direct translation, and intermediate code generation. Now, in this session, we are going to give a brief overview of some of the problems which are related to type checking and runtime environment. So, how the type checking takes place, and also runtime environment. With this concept, some of the problems related we are going to review brief. Say, for example, this is the example one of the problem, example 1. Here in this example, the statement that is given as A less than B or C less than D and E less than F. Now, A less than B is one condition, C less than D is one more condition, and E less than F. These are the three conditions. Now, without doing the short circuit implementation, without using the short circuit, we are going to give. That is, the sequence number is given as per the step, that is 1, 2, 3, 4, or any step number we can implement with this one. So, first the condition is to be evaluated with this one. So, here, if the condition is verified based on the result and this condition based on this, if either of them, then perform this one. So, based on this, the result is to be expected. So, first take A less than B. What is the condition? A less than B. So, that's why we will start with one condition, that is A less than B. If it is true, that means the condition is true, then we are going to move a step, that is 103. Where is 103? So, this condition is true. Then we are going to make a T1 equal to 1. That is satisfied. That is satisfied. Suppose if the condition is false, then we are not going to 103, that is that location. Instead of that location, we are going to take a next step, that is immediate step, that is T1 equal to 0. That T1 equal to 0 means false. So, we are going to evaluate the condition A less than B. If it is true, we are going to 101, that is 103, that is T1 equal to 1. Else, if it is false, then T1 equal to 0. These two statements are it. Then, if that is false, then immediately we can go to some other location, that is 104. That means we have to check the next condition. That means if it is true or false, it is completed. Even if it is true also, then we are going to evaluate this C less than D. So, that's why if C less than D, it is true, then go to 107. True case. Suppose if it is false, that means here we are going to next step, that is 108. 108 means once again we will check the condition, that is third, three conditions. So, third condition, this is the first condition, A less than B, C less than D second, and third one is E less than F. So, since E less than F is to be verified, if it is true, then suppose if it is false, then T3 equal to 0. Then based on this, false, 112 is executed. Then here the performance of the equation, that is the evaluation can be done, that is T2, T4 is evaluated with previous two, that means T2 and T3. So, what is T2 here? True, and T3. So, T2 and T3. And this is T1. So, T3, T2 and T3, which is stored in the result T4. Now, this T4, previous one is T1. So, that is T1 or T4. That is to be evaluated. T4 is T1 or T4. Then T, that is to be assigned with some T. So, T2 and T3, result is stored in T4. And T1, first one is, this one is T1. So, the T1 or entire result T4, which is assigned to some other temporary, say T. So, like this, we are going to evaluate the expression with this either the implementation of the logic is first condition is verified. We are going to check the condition. True means we are going to assign that value true. Else, if it is false, we will move to the another step, and based on this one or based on another step, it will move to the second. Once again, here condition is true, assign is true, false, then move to the once again another step where here condition check, true, t equal to 1, false, then assigned with move to the assign, go to another step. Here another step means performance of T2 and T3 verified, and then T1 and T1 or T4, and finally the result is stored in T. So like this we can evaluate this expression with the help of translations of this. Another one is call by value with this memory, that is symbol table, runtime environment, somehow call by value, call by reference. This type of problems are to be available. So now we will take small example related to call by value, where here the calling procedure copies the R value of the arguments into the called procedures, and activation records are to be implemented for noting down all these values, and formal parameters and actual parameters, which one is the. So here changing the formal parameters has no effect on the actual parameters. So that means while calling the function, some of the parameters are to be included, that is to be called, and then called and callee, both functions, it is matched with this corresponding, and then it verifies whether it is actual versus formal. Is there any effect or not? So, but in this case, there is no effect with the actual number, because simply we are passing the value only. If it is a reference, then there is effect on that one. So, for example, if you consider the add, so here add int c, but here we are going to print some c value, c equal to 10 plus c plus 10. And now in the main function we have described the integer value a equal to 5, so it prints 5. Now in mail, so here add a, so what is the add? So it is affecting any, so it doesn't affect. Why? Because there is no effect on the actuals and formal, so it prints 5 only. So prints main will not be affected by calling add, so it prints 5 only, and 5 only the value of c. In add it will be changed to 5 plus 10, that is 15. But in the add function it will change to 15 only when the value of c in add will be changed to 15. A equal to 5 only when only the value of c in add will be changed to 15. So here passing 5 and then getting that value 5 plus 10, 15. But what is the result finally print here after add a? So print the result with only with this value. So actual parameters and passing parameter values c and the corresponding a. Here both the parameters are to be verified if it is passed. Suppose in case of reference, call by reference, that is second one. Here calling procedure copies the I values of the arguments into the called procedure activation record. That means here address is passed. Address is passed to the called procedure. Previously there is no change with the actual and formal parameters, but here the difference is there is a change of actual parameters versus formal parameters, and it has some side effects also. Now in this program, if you see a pointer variable is assigned, that is c assigned to a function which is passed as a parameter in this add function, add method. Now we are going to take a value of a that is passed to the main function, and it represents print 5. Now here what we are passing the address reference. So address reference when you pass, then c equal to 15. Then c equal to, why? Because a equal to 5. A equal to 5, now you are passing as address reference. So address reference, so that's why here a equal to 15. Actual parameter is also modified. So here this is used for generally for the passing the large objects, and sometimes whenever we need to only the copy addresses, then only we are going to use. Because here we are passing the address reference only, add address of A, then the value that is to be affixed to this one also, and finally the printf statement that is to be get with the value of 50. Another one is call by name. So here generally this type of structures which is used in Algal, there is a programming language that is called as Algal, which is used this type of call by names reference procedures. And here procedure body is substituted for the call in the calling procedure, where the procedure is to be invoked. In that it is to be substituted. Procedure body means function body. Where function body is substituted at that time, this call happens. So we are going to make this as calling procedure. Each occurrence of a parameter in the called procedure is replaced with the corresponding argument. So it is similar to a macro expansion, and parameter is non-evaluated unless until this value is needed during the computation. Let us see with an example how this call by name execution takes place. Suppose here there is a method which is declared, that is show method, which accepts a value that is parameter value, that is argument with x, and within this there is a for loop which is described y equal to 0, y less than y plus plus, and x will be incremented. Now j is declared in the main function, j equal to -1, show j, that means we are calling the method. Actually j equal to -1 means internally it invokes by the name, that is show of j. So it invokes the for loop, where for loop is determined with the y value. So here incrementation of y and x, that is y each time the for loop executed, x value will be incremented. That means -1 with this one, that is -1 each time, that is x plus plus. So that means -1 plus 0, that is -1, and again -1 plus -1, that is -2. That's -1 plus -2, -3. Like that we are going to get the different values of this one. So why? Because here we are passing the name. Procedure body is substituted for the call in the calling procedure. Each occurrence of a procedure parameter in the called procedure is replaced with the corresponding argument structure. So this is the type of structure used in Algal programming. Another one is type checking of the things which are used in the compilation part. So first one is static checks, that is called as type checking, one of them. Here generally it reports an error whenever the operator is applied incompatible operand. That means this operand will be verified whether this one is compatible or incompatible. For example, in this case of declaration, we have used a float is f float, and a and c d. Now here f is float and a is integer, but c is array type. So this is and d is also integer. So this is an array type, but we have used a combination of c with d. That means this is not an array type, but this is an array type. So here this is not a compatible operation. That means we are performing addition operation. We are performing addition. We are performing addition with the index array with the corresponding the index with the corresponding integer. Here c is array type and d is integer type. Array type, integer type. Now the addition of these two is not matched. So that's why it gives this type of operand is called as incompatible operands. And similarly here star d is an integer type, and here a. So here this is not integer. Here we are considered as a d as integer, but star d it is a pointer type variable, but this is an integer type variable. So assigning pointer variable to an integer, it leads to an error. So that's why this type of is also makes to them as fail. So while performing the operands, we are going to check whether this passing the correct mapping checking or not. Based on that, it verifies. So here in this example, F, A, and array type C, and then D, and star D also related to different pointers, but applying the cases where this one is to get the results make fail. That is one type of check. Another check is flow control checks. Here in this type of checking, the example, for example, in this example, if you take, the function is to be defined with the break. But here generally the sequence of statements, that means the function statement with the list of statement 1, statement 2, break, and then S4, S3, something like that, S5, like this you have given. But while executing the function sequence of statements, S1, S2, S1 is executed, S2. So if you perform the break, then it gives error. Why? Because this is not allowed in case of the functions. Where this break allowed means here this it gives an error in this case, but here it won't give. It is okay. Where while loop structures or switch statements, this break statement. So here, what is the break? Here break means it stops the control, execution control, and then it comes out from that one. So it temporarily it stops that where the happens that one. So causes control to leave the enclosure. If it is in the while loop, executing the statements, if whenever this break encounter, it comes out of that, leave that one, and for loops statement also, and enclosing break does not exist in these statements. Suppose if enclosing within the function, we can use this switch statement. Within the function, we can use for loop, while loop, and we can implement the break. But inside the function, we cannot use. So this is the why? Because the flow of control changes from one place to another place, and the transfer of control taken place in this case. So generally, we can implement this break statement inside a switch statement or while loop, and other than this, if you implement this one, it causes an error because the loop it cannot leave outside that function. So this is the one of the type checking process in case of compilation. Another one is uniqueness check. Uniqueness means generally there is a possibility of appearance of the variable several times. That means we have defined the object one time. Maybe after series of steps, we may forget the same variable is declared or not. Once again, a reappearance takes place. So that is called as checking of uniqueness. Where suppose here in this one, I variable is defined, j is defined. Once again, I. So this is the twice. In this example, the function is defined. The function is defined with the variable I twice. So twice or thrice appearing repeated. That means I is appeared several times. So here also suppose the function is defined, argument 1 is A, argument 2 is also A. So here also defined twice. So it is not allowed to give that name several times with the same name. So you can give the different name, int A comma int B, so that it is a valid function name. With this one is a valid. So here also you can write I comma J comma C like this. This is a valid. But repetitions are is to be verified in base of compilation process, and this type of error comes under as uniqueness. Suppose a structure is defined with some record name, with the name integer name. Once again, the structure is defined, another structure. This is structure 1, this is another structure. So two structures are defined. So both structures have the same name. So this structure is record, my record, and this structure also have the same name, my record. So this is not allowed in case of this if at all, if it is written also, it comes under as type checking process. It will be emulated, and this type checking is called as uniqueness checking. Because if I retrieve some name, your my record dot name, so which one is used to be called? Why? Because my record it is allowed. Similarly, my record dot id is also allowed. Both are valid. But here, what is my record? Can I consider my record here? Name is not there. So which structure which can be considered? There is a, it leads to a different solution. So that this is comes under error. And this is also repetition of a, it is also comes under an error. Now repetition of I variable, it is also an error. So like this, we are going to verify several possibility of the cases where the error notations are to be identified. That means more than one declaration twice, thrice in case of function, while declaring variables, declaring same variable names several times, or function arguments with the same name several times. Here this is the first, this is the second. So first one declared the variable names several times. Second one is function arguments with same name. And third one is here giving the structure names, same with the same name, giving the structure name same multiple times giving the structure name. So all these cases, it gives an error reporting, saying that whether this one is accepting. Suppose that is to be written, even though the compilation point, it will checked with the uniqueness. Previous one is type checking with incompatible operand. Suppose instead of integer, we have declared float value and performed the operation with another operation such as float or pointer type. Then any assignment takes place with integer which pointer. Like this, this one is checking of each individual data item. That is called as type checking. Each individual data item of the correct type or not. Each individual data item can be checked thoroughly. With the corresponding data type only. Suppose instead of that, any other type with operation performed, that comes under incompatible operation. So compatibility is required means where where you are going to perform the operation, both should have the same type. And while sequence of statements are to be executed, where the break is to be encountered, we are going to take this as a precautionary measure. We cannot use this type of break statement inside the function. It is not allowed. Even though if write, this comes under as a flow control. This type of checking is called as flow control checking. And uniqueness checking means we can use the variable or the argument only once, more than once in the same type of function, in the same declaration type or function names or structure names. Then it comes under as a error notation, and this is also can be avoided. This type of checking is called as uniqueness checking. Another one is name related checking. In case of name related checking, we are going to verify whether the same name is appearing several times. That means here we are going to verify at the beginning and end of the constructors. Constructs, we are going to give some names at the beginning. Suppose if the loop is, in this example, a loop is mentioned with one construct is at the beginning of the construct, one loop is observed. And at the end of the construct also, we observed some of the loop. But if that is appearance is same or not, it will verify. That means suppose if that is not same, that means same name must appear, but here it is a different name. So it gives a error, name related error checking. This type of checking is called error. That means we are going to repeat the loop several times if the condition checking, or sometimes. So here we may forget to say instead of loop A, we have given loop B. So this is the comes under name related. This type of checking is called as name related checking. So like this, some of the checkings are to be. The first one is called as type checking, where the different types of the operand data types declarations itself verify, and after checking we are going to verify whether this is compatible or not. That is name related checking. That is name related and compatibility also. While performing, suppose C plus D we are performing, then what is the type of this one? What is, so it is compatible. If it is an integer, it is an integer. Okay. Suppose if it is a different, if it is a pointer type and it is an integer type, so these two are incompatible. So that is to be while in the process of compilation, it will verify, strictly verifies whether these both are compatible or not. Any incompatible occurs, then it says that failing of the operations. And flow control checks also verified, where the break statement encountered in between while statement or switch statement, it is allowed. In case of function, it is not allowed. And third one is an uniqueness check. That means a repetition of several variables inside the function, and also inside the function arguments, argument names, inside the declaration of types, and also inside the declaration of the function names, and also structure names. So in all the cases it is allowed, but make sure that it is, if it is the same, then it gives an checking called as uniqueness. That means more than one time it appears, then the type, see that there is only one type will be, more than type it is not repeated. If repeated, then definitely it comes under as an error. So we have to make sure that it defines uniquely exactly only once. So it leads to a different solution and may not get the final result. So at the compilation itself, it checks this type of checking also and gives an error. And another one is name related also. So if the same name appears at the beginning of one construct and end of the construct, then it resolves they may not get the result solution. So instead of that, we have to use the same name so that errors won't affect. So this type of checking also can be done in case of compilation process. And this is called as name related checking process. And these things which we discussed can be available in the book, that is Compilers, Principles, Techniques and Tools, that is Alfred C. Willman. Thank you all of you. Thank you. Next class will come on, in the next session we'll come up with one more problem solving technique in the case of syntax directed runtime, syntax directed translation and runtime checking environment. Thank you once again. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.